Well, here we go, folks. If you're watching this, that means you've logged in and found today's instructional materials for our remote learning. We're going to talk about solar energy today briefly. We've been talking about all kinds of different energies, their advantages, their disadvantages, the conversions that occur, and certainly we'll tackle the same topics here with solar energy. This is one of our really popular renewable sources of energy you hear a lot about right now. Hopefully, you followed the directions under the remote learning instructions, and you've already watched that 5-minute TED video as well as the 2-minute student energy videos. Those are all really good. They help familiarize us with these energy productions before we jump in and take some notes and clarify some things here. So hopefully you've watched those. If you haven't yet, pause this video, go back, watch the things you need to watch, and then come back and we'll finish up our notes. So the idea here is that you're watching along with me. You can pause the video. You can fill in your own note sheet in Notability. That'll help guide you on your assignment a little later. It's going to be just like the assignments we've been doing, where you fill in the energy types at each interval and describe it in your own words. So let's jump right in here. Let's talk about solar energy conversions. You may have caught in those previous videos that solar energy is the most widely abundant renewable source of energy on Earth. The sun, 93 million miles out there in space. Nuclear fusion is emitting massive quantities of radiant energy that even at 93 million miles away still bathe us in a lot of energy every day. So that's going to be our first energy type coming from the sun. We've got number one, we've got radiant energy, radiation coming down in the form of visible light. Those photons are coming down, and the whole goal of a solar photovoltaic array, which is the form we're thinking about, is it's going to convert that radiant energy directly into electrical energy. There's only one conversion, radiant straight to electrical, which makes it really simple and kind of elegant when you think about it. They talk about it in the TED video a little bit more specifically, but they talk about this idea of a semiconductor, which is right in there. It's a special layer in between this sandwich of the photovoltaic array. That semiconductor, as they mention, allows protons, these little positively charged guys here, to flow through, but it does not allow electrons. So let's think about that atomic structure again. Way back in our chemistry unit, we learned that atoms are composed of protons, these positively charged particles, with electrons, these tiny little negatively charged particles orbiting around them. And so all atoms are composed of those things. Now, the neat thing here is that semiconductor right there, when that radiation comes down from the sun, it excites those particles in the solar array, and it shakes those electrons loose, and it allows those protons, which are positively charged, to flow through to the bottom of the solar panel. The electrons really, really want to meet up with those protons again, but all we do is, instead of allowing them through that semiconductor, through that special layer in the middle of the solar panel, we force them to flow the long way around. And there's a good example showing those electrons flowing the long way around. They have to go the long way to get to the bottom. And they flow through a wire to do it. And what do we call flowing electrons? The flow of electrons in one direction, we call that electrical energy. And we can harness that electrical energy. Those electrons on their way to the bottom of that photovoltaic array, that's called electricity, that flow of electrons. So right in here, we've got our second form of energy in the flowing electrons we call electrical energy. So it's kind of complicated, but also like really simple at the same time to have electrons that really want to flow around and meet up with their protons. They really want to, they're attracted to that positive charge. Remember, those opposite charges attract. But instead of allowing them to go the nice, short, simple way, we force them the long way around. And in the process, we create electrical energy. Pretty cool stuff, but you got to have sunlight to do it. So let's go back here. Let's take a look. Down here, we'll add to our notes. So let's go in here. Let me open this up. Foundations. On our note sheet here, we're going to say that a solar panel, its job is to absorb sunlight, which is radiant energy, and convert to electrical energy by forcing those electrons to go the long way around. And remember, we call that PV. Solar panels are an example of PV, or photovoltaic. And voltaic, volts, right, is how we measure electricity. Photo, meaning light, electricity, photovoltaic. Cool. So just like all of our other forms of energy here, we need to think about some advantages and disadvantages. Obviously, solar energy is not the solution to everything, or we would have already switched over completely, but it's got some major advantages. Number one is that there are no greenhouse gas emissions. Think about it. Nothing's burning, right? There's no combustion. So we're not emitting any carbon dioxide or any of those other harmful greenhouse gases. We'll say no greenhouse gas emissions here. That's pretty awesome stuff in a world where we worry about greenhouse gases. And lastly, and maybe I should have listed this first, but it is absolutely renewable, and it is listed as the #1 renewable energy source on Earth. Sunshine. The sun shines every day, and we can harness that and turn it into electrical energy. Now, there are some disadvantages here with solar power. Remember, it's not available 24/7, right? And at nighttime, we're not making solar power. And remember, baseload energy, we need electricity being produced 24/7 to be able to utilize energy whenever we need it. That luxury that we like to have. So it's not available 24/7. Bright sunny day here in Maine, tons of solar power we can harness. Cloudy day, not quite as much. Nighttime, really none that we can get. So we still need other forms of energy to provide that base load power, but solar can be a great supplement even in a place like Maine. But I love how they point out some of the possibilities there in that TED video with floating solar farms and deserts and things like that. Speaking of that, though, another disadvantage identified by a lot of people is that they have a generally large footprint. And by that we mean they take up a lot of space. To produce like commercial loads of solar power, we need huge solar arrays. And let's go take a look here. We can look at like, let's look at a solar farm, they call them. If we look up images of solar farms here, we're going to see, you know, places all over the world where we're producing kind of commercial levels of solar energy. But holy cow, look at the size of the footprint on the land if we want to produce large amounts of solar energy. Now, they list things like deserts and places like that as good examples of A, places that have lots of sun, and B, areas where the impact on wildlife and habitat wouldn't be as much. But keep in mind, even in deserts, there's still wildlife, and we're creating, you know, we're changing the habitat for sure when we put in these giant solar farms. Here are some examples of ways we can mitigate that. People building solar farms over, you know, a man-made pond already. Or there you go, there's out in your desert. But again, that is not natural desert habitat. If you look over here, you can see kind of that scrubby desert vegetation that they've all cleared out to produce this, to put in this giant solar array here. So tons of examples all over of solar energy production and interesting stuff. But yeah, another way to mitigate that human footprint would be to put these solar arrays on places that are already disturbed by people. They show in a couple of those videos, what about rooftops? We've already built a house on a spot. Why not cover the roof, or a big skyscraper or any large industrial building, cover the roof with solar arrays? It's already space that's been taken up by people. We can make it multi-use and produce electricity with it too. So there's tons of opportunity. The price on this stuff has come down quite a bit. It's becoming more cost effective to make solar energy. And it's certainly a source of energy we're going to see constantly increasing in the future. Another major advantage here, you'll notice, no moving parts, right? There's nothing that needs to be oiled or greased, and these things are becoming more and more resilient all the time. You can put them in, and they'll run pretty well in some cases for decades without any sort of maintenance, without any moving parts or anything to constantly be doing upkeep on. So there's definitely some advantages to solar, but a couple of those key things keeping it from really taking over. But I think we'll see more and more solar production as time goes on. So go ahead, use these notes to complete your assignment. That's also posted in Google Classroom. Just a real quick little breakdown of the energy types involved, as well as your verbal description in nice complete sentences of what's going on with solar energy production. Looking forward to getting you guys back in the classroom here in the future, and hang in there, and I appreciate your effort here with this remote learning.